In this research, we propose a new method to synthesize animations of multiple characters competing with each other while satisfying the overall requirements of the animator. We first capture the motion of a single actor. Then we construct an action-level motion graph. Each character expands a game tree and evaluates the long-term benefit to select the optimal action. Using this method, we can simulate dense interactions of multiple characters. The competitive function evaluates how well the characters perform in a competition, such as fighting. The cooperative function evaluates how well the characters help each other to achieve the request from the animator. In this case, the request is to follow a given path. We combine the two functions when expanding the game tree, hence we generate intelligent characters that can compete with each other while cooperatively following high-level objectives. Here we show our experimental results. We create a motion database with motions of a character fighting with a weapon. Here is the captured motion. We can simulate two characters fighting with each other by using tree expansion. The characters consider the long-term benefits when launching actions and hence act intelligently. Here is a typical scene in a movie where a weak character is attacked by a strong enemy and then a hero character joins in to knock down the strong enemy. The three characters cooperate with each other to follow the storyline. We can design the trajectories of multiple pairs of characters. Since the trajectories are defined in the spatial and temporal domain, the characters will not collide with other pairs unexpectedly while interacting with their opponents. The characters wearing red gloves are requested to knock down their opponents when reaching the end of the trajectories. Each pair act cooperatively to achieve this goal. With this framework, an animator can easily specify the formation of competing characters. We also created a motion database of kickboxing. Here is the captured motion. We can simulate different styles of interactions by changing the objective function that evaluates them. Here, the upper characters fight as infighters that are more aggressive and prefer short-range attacks, such as hook punches and uppercuts. The lower characters fight as outboxers that are more defensive and prefer long-range attacks, such as straight punches. Here is another typical scene in a movie where a hero character is attacked by a strong enemy in the beginning, but wins at the end. The two characters cooperate to reach the checkpoint where the enemy is hit by a car. In this experiment, we created a scene with many pairs of fighting characters. They follow the user-defined spreading out formation that is visualized by the red area. We also define a cooperative constraint such that the characters with red gloves knock out their opponents when they reach the end of the trajectories. Again, since the movements of the characters are constrained, they will not run into other pairs. Finally, we created a motion database for a character running around in a small area. Here is the captured motion. We can create a scene in which the two green characters catch the blue one by expanding a game tree of 3 characters. By specifying the trajectories of the characters, they can chase around in a constrained environment. We can also put in multiple pairs of characters. Since we spatial-temporally constrain the movement of the characters, we can minimize the risk of unexpected collisions and generate a realistic scene effectively. In this experiment, we compare our method with the interaction patches. The characters controlled by interaction patches do not follow the line given by the animator well, because the number of available patches is limited.